Welcome back, and we are doing 4.6 related rates. I'm going to be showing you how to use 12 simple steps to solve related rate problems using this graphic organizer. So, step 1 is reading and interpreting the problem. We're going to jump right into it. So, two cars are traveling along perpendicular roads. Car A is at 40 kilometers an hour and car B is at 20 miles an hour. When car A reaches the intersection, car B is 100 kilometers north and moving towards the intersection. Find the rate at which the cars are separating from one another 2 hours later. So, let's evaluate what we know here. First off, car A is going at 40 kilometers an hour and car B is at 20 kilometers an hour. That is their rate, or the derivative, of position. We also know that when car A is at the intersection, car B is going to be 100 kilometers north, and we will be finding 2 hours later. So, the next step, sketch a diagram of the problem. In this case, our diagram is going to be put in this category. It says draw a picture and label. So, what we have is we have car B coming in this way, and car A came from over in this side and is heading in this direction here. So, this is car B, this is car A. Now, what we do know is that they are going to have a position relative to each other. We know that the length of this is 100 kilometers north when car A is at the 0 position, and we know that they're going to have this connector with a distance. So, this is 100 kilometers north. This section of the triangle is going to be 100 subtract y, and this portion up here is going to be y. This is a right angle because they're perpendicular. This side is going to be x. Okay, so we kind of have a diagram, but understanding it's a different thing. So this point here and this point here are where the two cars are in relation to each other, and this line is the distance between them. So, our third step is going to be to determining the purpose of this problem. So what do we want to find out? Well, if we go back to our question, it's find the rate at which the cars are separating from one another 2 hours later. So we're looking for the derivative of the distance in relation to time. This is what we're trying to solve for. It's the rate in which cars are separating. So remember this for later. Our fourth step is going to be locate any given constants in the problem. In this case, we know that car A is going to be moving at 40 kilometers an hour, so that's going to be derivative of x, because that's car A, in relation to time, and it's going to be 40 kilometers per hour. Now we also know from the problem that car B is moving at 20 kilometers per hour, so that's going to be derivative of the y in relation to time is equal to 20 kilometers per hour. With me so far? Okay, so step 5, and I do recommend writing these down. You probably will not need them in the future once you figure out how to do it, but at least for now, try and go with these steps. You're going to be locating the point in time in which you're solving for, which is 2 hours later. This is just another constant, and you need to put that in this section. So we're looking for t is going to equal 2 hours. So we have all of our given information in, we know what we're solving for, and we kind of know what this problem looks like. The next step is going to be to write an equation that relates the variables in the diagram. In this case, Pythag is going to be the easiest way to do that, and we're going to write that in this equation here. Note this right here. Do not include any points of time in the information. If you do, it'll mess it up and it won't work out. So this is what the equation is going to be. I'll explain it in a second. Many of you are probably already recognizing that this is just simple Pythagorean theorem. This right here, 100 minus y squared, or 100 minus y is then squared. The x is squared and the d is squared. So all you're doing is you've set up the relationship of this right triangle. The next thing you're going to have to do in step 7 is differentiate all parts with respect to t. So, and you're going to do that in this right here. So, don't forget chain rules. So you're going to have 100 subtract y times -1, because the derivative of the inside is going to be 100 is 0 and -y is just going to be -1. And because of this 2, this exponent up here, you're going to have a 2 out front. And then dy dt. It's going to be plus, again, because you have the squared here, it's just going to be 2x dx dt. And then finally it's going to be equal to 2d dd dt. Okay. So we now have our equation, but one thing you're going to notice is that there are 2's on all terms on both sides of the equation, so you can just get rid of that. Just divide both sides by 2 and that problem is eliminated. So step 8, you're going to write your problem or what you're going to be solving for right here. So you're simplifying. This is essentially what you're doing. And I tend to do this just so that I know that that's one step. I also draw one other box in here, and you'll know why in just a second. In our next step, we're looking at finding the distance traveled by each of the cars using the given routes, or given rates, sorry, and point in time. So, most of you at this point will know that distance is equal to rate times time. And we can solve for each of our variables using this. So x is going to equal 40, because that's our rate, and our time is 2. So this is our rate, this is our time. 40 times 2 is going to equal 80. And y is going to be the rate of 20 times time of 2 equals 40. Okay, what's our next step? Oh, right, writing solutions back in with the rest of our given information. So we can then take this and put this back in with the given constants. So we know that our y is going to equal 40, we know that our x is going to equal 80, and we know that our distance is going to equal 100, because if you use the Pythagorean theorem and stuff, you'll be able to figure that out. Our next step is going to be plugging in all constants into the relationship equation, which is this right here. So this is actually when we're actually going to do the solution. I'm just going to highlight some stuff for you. Notice these things right here are actually our constants. And this one over here is our solution. So this is what we're trying to find out. But these here we actually have, because if you look, dx is going to be 40 kilometers an hour, and the dy dt is going to be 20 kilometers per hour. So that, plus we can plug in the y and the x and the d, will allow us to solve for dd dt. So I'm just going to do that here. I'm not going to talk about it or anything. Just follow along. So we're going to have -60. Again, this is what we're solving for. Divide both sides by 100. Okay, so we now have our solution. We know that they are going to be moving away from each other at a rate of 20 kilometers per hour, I think it is. Yes, 20 kilometers per hour. So we're going to write that down. And this is our final step of writing the solution. Cars A and B are separating from each other at a rate of 20 kilometers per hour. Whoops, I put two ats. So that is 4.6 related rates, how to solve related rates problems using a graphic organizer, and thank you for joining me.